This video will show how you solve a system that has no solution or infinitely solutions, or what the solving process looks like in these cases. Now with no solution, that's when you have a situation of parallel lines, so lines that do not intersect. So this system would have no solution if we were to graph it. And then infinitely many solutions means that the two lines are in fact the same line. So in that case, if you were to graph, you'd graph one line, and then when you graph the second line, it would be the exact same line. But when we're solving these two types of systems, either parallel or the same line systems, they look a certain way as we're solving. So let's try to solve these two systems using elimination. In this first example, 6x plus 2y equals 10, 9x plus 3y equals negative 4, the easiest method to solve would be elimination, and elimination by lining up the y's. So recall with elimination, we want the same number in front of the variable with the opposite signs. So we would want to get 6y and negative 6y in this system. So to get 6y in the first equation, we'd multiply it by 3. Doing that, we would get 18x plus 6y equals 30. And now to line up the y's with the second equation, we want negative 6y, so we multiply the second equation by negative 2 to get negative 18x minus 6y equals 8. And now the elimination step, we add these equations together, and we find that 18 minus 18x cancels, 6y minus 6y cancels. We get 0 then on this left side, and we have 38 on the right side. So you can see that this result here is false. 0 is not equal to 38. So if you ever try to solve a system of parallel lines, you end up with some statement that is just false, a statement that cannot be true. Now when you're solving a system with infinitely many solutions, something else happens. In this system, let's line up the x's. So since we have 1x and negative 2x, we could line up the x's with 2x and negative 2x. So we'd multiply the top equation by 2. And we'll leave the second equation as it is. So multiplying the top equation by 2, we get 2x minus 8y equals 14. And then the bottom equation we'll just leave exactly as it is. So negative 2x plus 8y equals negative 14. And now at the elimination step, when we add these two equations together, the x's cancel and the y's cancel, so we get 0 on the left. And on the right, 14 minus 14 is also 0. So we end up with this true result because 0 is equal to 0. So if you're ever solving and both variables end up being eliminated and you have a statement that's true, that's when you have infinitely many solutions. But in the case before, if you get a statement that's always false because 0 is not equal to 38, then you have no solution. So in both of these cases, both variables end up getting eliminated. It's just whether the result ends up being false or true at the end.